Hey everybody, in this lesson we're going to be talking about solving systems of functions. So a system in general is when you're talking about more than one at a time. So when you're talking about a system of something, it's like more than one, usually equations or inequalities, depending on what it is that you're talking about. In this case, we're talking about functions. So a system of functions is when you have more than one function. A solution to a system of functions is basically the points or intersection in which the graphs both cross. So the point of intersection. So when you're talking about, for the first example, find the solution of the system of functions, we're talking about find the place where those two functions cross or intersect. So let's first graph each of the functions. Let's say we start with f of x is equal to negative 3x plus 6. If I want to graph this, my y-intercept starts at positive 6, which is going to be up here somewhere. A little above the 5, so I'm going to go ahead and just call that 6. Then my slope is negative 3 over 1, so I'm going to go down 3 spaces and then to the right 1. I'm going to keep on following this pattern, down 3 to the right 1, down 3 to the right 1, over and over again so I can get a straight line. Once I have all of my points connected, then therefore this is my linear graph for the first equation or the first function, f of x is equal to negative 3x plus 6. Now, if I were to do the same process with g of x, in this case, my y-intercept is going to be at positive 2. So I'm going to start at this point right here. The number in front of the x is a 1, which I will label as 1 over 1. So that means that I have to start going up 1 and to the right 1, go up 1 to the right 1, go up 1 to the right 1. I can also go down 1 to the left 1 over and over again because all these points will eventually land on the same line. So I can make as many points as I want, and it will not change the outcome. It's still talking about the same line. Okay, so therefore we have two linear equations, or two linear functions in this case. We have the graph of f of x and we have the graph of g of x. Now, if they're talking about the solution, which we established earlier that the solution is the point where the graphs intersect, what would be the solution to this system of functions? As we can see from the graph, the solution to the system of functions is where they cross, which in this case happens to be here, at this point. If we were to graph this point, remember every single point has an x and a y, the x-coordinate for this one would be 1, and the y-coordinate for this one would be 1, 2, 3. So therefore my solution is 1, 3. So the solution is where the graphs intersect or cross. It's just a fancy mathematical way of saying cross. Okay, so now that we know what a solution is, eventually every now and then they give you the same exact type of problem, but they give it to you looking in a different way. So on the SBAC, a lot of the times they give you something that looks like this. It says find where f of x minus g of x is equal to 0. So if you have two functions, f of x and g of x, find out where they are equal to 0. Let's say we wanted to figure this out algebraically, right? So let's say I don't know anything about anything. I'm like, okay, f of x, I know that f of x is equal to this. So what I'm going to do is I'm going to go ahead and plug it into the equation that I have there. So it's going to be f of x minus g of x, and then I'm going to set that equal to 0, as the original equation states. Now, instead of f of x, obviously we have the equation of negative 3x plus 6. So I'm going to write here negative 3x plus 6. And instead of g of x, I'm going to have the equation that they give me, which is x plus 2. So if I simplify this, in front of the parentheses, I have a negative 1. So that means that I have to do the distributive property of multiplying everything by negative 1 here. The left-hand side, everything stays the same. I just drop the parentheses because there's nothing in the front. So I'm going to write negative 3x plus 6. And on the right-hand side, I will write negative x minus 2 is equal to 0. Now, since I only have one variable here, I only have the variable x. Essentially, I want to solve for x so I can figure out what my where this function would be true. So, or this equation would be true. So when I combine like terms, I get this and this that can be combined into negative 4x. And I can also combine this guy and this guy, the 6 and the negative 2, as positive 4. Still, I drop down the equal to 0, and then I want to solve it, right? So I draw the wall. subtract 4 to both sides so I can get the x by itself. Drop down the negative 4x, so negative 4x drops down, this goes away, the negative 4 and the positive 4 cancel, and then on the right hand side, all I'm left with is a negative 4. Now the final thing I need to do is to solve for x, I have to divide both sides by negative 4. So divide this side by negative 4, divide that side by negative 4, and my answer is x equals 1. What does that even mean? So basically what that means is that I figured out where this equation is true, right? So this equation is true where x is equal to 1. If I want to find my y, all I have to do is plug it into any one of these equations to figure out the y. Let's say, for example, I want to plug it into this guy here, into the g. I know that x is equal to 1. So when I plug in 1, g of 1 is going to be 1 plus 2, which is going to give me the value of 3. If I want to plug it into the f function, let's say I wanted to plug it into this one. Same thing. I want to plug in 1 into the function f. So f of 1 will be negative 3 multiplied by 1 plus 6. That'll give me negative 3 plus 6. And then negative 3 plus 6 is just positive 3. So no matter what, I got the same answer, right, for both f and for g. So when I plug in 1, I get the answer to be 3. So what does that mean? That means that my this equation is true. F of x minus g of x is equal to 0 at the point 1 comma 3. Now this is not a coincidence. So if you notice, I give you guys the same example that I gave you guys last time. I don't know if you guys caught on to it or not, but this is the same function for f of x and for g of x. And when we graphed those two functions, what we realized was that the point of intersection is the point 1 comma 3. So that means that the solution is 1 comma 3. So what the heck, right? So they're actually asking for two different things, but yet we end up getting the same answer. This is what actually happened. They're actually asking you for the exact same thing in a different way. So I'm going to go ahead and erase this, and I'll show you guys exactly what that means. So when they ask you where the function f of x minus g of x is equal to 0, they're actually asking you where the functions are set equal to each other. But some of you guys may or may not have noticed that in order for you to get that, you have to set the equations equal to each other. So the way that we do that is basically getting the f of x or the g of x by itself on top, and then dealing with the solutions afterwards. For example, so when you have something like this, f of x minus g of x is equal to 0. If I want to get the f of x by itself, all I have to do is draw the wall, add g of x to both sides, and then we're done, right? Because the negative g of x and the positive g of x cancels out. So we get the equation as f of x equal to g of x. So essentially, what they're telling you or what they're asking you to do here is figure out where the functions are equal to each other. Or what is the solution? So they're actually asking you in a different way, what is the solution, right? When they say f of x minus g of x is equal to 0, it's the same thing as if saying, where are the functions equal to each other, which essentially is just called the solution. Some of the times they won't tell you, but a lot of the times they might give it to you like this, especially in the aspect, so you want to be ready for that scenario. So the solution is where the functions cross, or the functions intersect. It is also where the functions cancel out or equal to 0. So essentially, if we were to graph this, we get the exact same graph as last time, right? So last time we said that it started at positive 6. We go down 3 over 1, down 3 over 1, down 3 over 1. And this will be my first line, which we had already graphed. Pretend that's straight. On the second one, we graphed it at 2, and then we go up 1 over 1, up 1 over 1, up 1 over 1. So this is my second line. And then my point of intersection is the exact same thing that we got last time, which is actually right there. That is point 1 comma 3. Sorry that the line's not straight, but you can look at the last example for it. So now that we know what they're asking, most of the time they'll give you something that already has a graph. For example, something like this. Let's say you want to figure out what is the graph, or what is the point of intersection, in this case where f of x minus g of x is equal to 0. So we know that this is just another way of saying where the functions are equal to each other, right? So where's half of x minus g of x equal to 0? That's just asking you, where are the solutions? Where do the functions cross each other? By looking at the graph, this function, the orange graph, the orange parabola, and the blue parabola, or those two graphs, can touch each other at these 2 points, -2, +4, and +2, -4. So the solutions, without actually having to do any work, are -2, +4, and the other one will be a +2, +4. That's it. The hard part is really figuring out what the heck are they asking when they're saying this. And they're actually asking, where do they cross? Simple as that. Okay, last example. So let's say they give you something like this, same exact question, but different graphs. So they are saying, find where f of x minus g of x is equal to 0. Once again, they're asking you, where do these two functions where are these two functions equal to each other, or where do they intersect? So by looking at the graph, where are these two functions equal to each other? Well, as you can see, there's only one solution in this case because there's only one point of intersection. And that point of intersection is right there where they cross at that single point. If you were to give me the x and the y coordinates of that point, the x coordinate will be at +4 and the y coordinate will be at -5. So therefore, there's only one solution. So the solution where f of x minus g of x is equal to 0, and also where f of x is equal to g of x is at 4, -5. X equals 4, y equals -5. Okay, so I hope this video was useful. See you guys in the next one. Good luck.